Find the value of x such that the integral from 1 to x of 3 over t dt is equal to the integral from 1 over 4 to x of 1 over t dt. Okay, so we can just move forward directly and integrate the two expressions on the left and the right of the equal sign, and just hopefully we get to an answer. To integrate this, I really want to think of this 3 as being in front of the integral. So it's 3 times the integral of 1 over t dt. Therefore, it's 3 times ln of t that I'm integrating from 1 to x. On the other side, again, it's the integral of 1 over t dt, so it's ln of t over the interval 1/4 x. Plug in x, plug in 1, 3 ln of x minus 3 ln of 1 equals ln of x minus ln of 1 over 4. I can subtract ln of x on the left and on the right. By the way, there should be absolute values here. I don't need absolute values for ln of 1 because 1 is positive. I don't need absolute values here for ln of 1 over 4 because 1 over 4 is positive. So I'm going to subtract ln of x. I get 2 ln of x, and ln of 1 is actually equal to 0. So this whole thing is 0, equals negative ln of 1 over 4. Now if we think about the context of this exercise, because we were integrating 1 over t or 3 over t, we have a discontinuity at t equals 0. So we're never going to go past x equals 0 on the left in the negative values. That's beyond the content of AP Calculus AB. So we can assume that x is a positive value. 2 ln of x equals negative ln of 1 over 4. And here we need to use properties of logs. One of them is ln of a times b equals ln of a plus ln of b. We'll use this again in a few minutes in another exercise. Ln of a over b equals ln of a minus ln of b. And finally, ln of a power b is b times ln of a. And that's the one we're interested in right now, used from right to left. We have 2 ln of x, 2 ln of x, it's equal to ln of x squared. And we have negative ln of 1/4, so it's ln of 1/4 to the power of negative 1. ln of 1/4 to the power of negative 1. What is 1/4 to the power of negative 1? It's 4. So ln of x squared equals ln of 4. X squared equals 4, and therefore x equals 2. Again, we won't have x values that are negative because we would be integrating across a discontinuity that is beyond AP Calc AB. A population P of bacteria is changing at a rate of dp/dt equals 3000 over 1 plus 0.25 t. T is the time in day, and we also know that the initial population is 1000. Every time you see the word initial, it means at t equals 0, or when t equals 0. Write an equation that gives the population at any time t, and find the population when t equals 3. Alright, so this is the derivative of p. So if we want to find p, which we can just write p, or we can write p of t to specify what the variable is, we're going to want to integrate that. So I can say the integral of this equals the integral of that. And when we integrate that, I want us to think of this 3000 as being in front of the integral sign. And now we're trying to integrate, oh, I forgot. If I put an integral sign, I should have dt here. But, well, doesn't matter. Now I want us to think of this as 1 over 1 plus 0.25t. Since this is a linear equation, it's t power 1, the integral is ln of 1 plus 0.25t, but we have to be careful now and think backwards. What would happen if I took the derivative of that? I would get 3000 times 1 over 1 plus 0.25t times the inside derivative, which is 0.25. So in order to compensate for that 0.25 that would multiply my whole thing, I need to actually write 12,000. Now when I take the derivative, it's going to be 12,000 times 1 over 1 plus 0.25t times 0.25, so 12,000 times 0.25 will give me the number that I actually want. And finally, plus c. In order to find this constant, I'm going to use the initial condition I have. 1,000 equals 12,000 times ln of 1 plus c. ln of 1 equals 0, and therefore c equals 1,000. So I can rewrite this and instead of putting absolute values, I can just put parentheses because t is going to be positive. We're starting at 0 and we're going to the positive, so ln of that number here is always going to be positive, plus 1,000. And finally, if we want to find p of 3, we just plug 3 in, and the answer, I believe, is 7,750. So that's very easy. You just put a 3 here and you use your calculator, obviously. The last exercise we will do in this section is the following. True or false, the integral of 1 over x dx equals ln of cx, c not being 0. I prefer to think of this exercise backwards, actually. Instead of trying to integrate and see if I can get this, I would rather differentiate ln of cx and see if I get 1 over x. So the derivative of ln of cx is 1 over cx times the inside derivative, which is c, and I get 1 over x. So it looks really easy like that. We see immediately that that works. Now remember that we mentioned earlier the properties of logs. Ln of cx would be ln of c plus ln of x. Now when you think about that, the derivative of this is clearly 1 over x, because the derivative of that is 0. This is just a constant, plus the derivative of ln of x. So we can actually now do it in the order it's given. We know that the integral of 1 over x is ln of x plus c. When you think about that, c is the ln of something, maybe k. And now I can group these two things together using the properties of logs. That's ln of kx. So I have a k here, it's a c originally, but that shows that the integral of 1 over x dx can always be written as ln of kx.